Hello everybody. Today we're going to be learning 9-7 factoring special cases, and we have a little visitor today. I hope he doesn't distract you too much, but he's cute, huh? So we'll see how this goes. If he gets too fussy, his papa will take him away. But anywho, I want to remind you, a couple of sections ago we talked about perfect square trinomials, and we were expanding them. We started with things like a plus b squared, and we learned how to expand them into a trinomial, a squared plus 2ab plus b squared. And now we're going to be going backwards, because instead of expanding it, we're going to be condensing it into a factored form. So we'll go from having a 3-term polynomial to having just a binomial squared. Remember that if this is a minus, it means that this will be a minus, and vice versa. If it's a plus, it'll be a plus. So just wanted to remind you of that, and we're going to show you how to go backwards today. Here's an example. There's actually 2 ways to do this. So I'm going to do method 1, and then I'm going to show you how to factor using our previous method, and you can of course use that method as well. The key here is to rewrite, to recognize first and foremost, if you look at the previous formulas, that you're looking for a squared and a b squared, and then you want to make sure that 2ab actually works out. So in other words, if this is going to be, and it's a question at this point, if this is going to work as a minus b squared, then I have to basically identify what a is and what b is. So in this case, a would be x, and so a squared would be x squared, which it is, and b would have to be 4, because b squared would be 4 squared, which is 16. So you've got that. So what you want to do is rewrite this as x squared plus b squared. And as we learned before, the middle term should be a negative 2ab. So if a is x and b is 4, then negative 2 times 4 will be negative 8x. And since that checks, then we know that this is in fact the right format. And so to factor it, I would just write a minus b quantity squared. So if a is x, this would be factored into x minus 4 quantity squared, and I'd be done. Now I want to show you that if that's too complicated or you just don't like it, you can still use the plus that we've been using in the past. You still want to put a 1 and a 1, because the factors of 1x squared is 1 and 1. And then what's going to happen is that when you find factors of 16, it's going to be 4 and 4. 4 times 4 is 16. And if you make them both negative, negative 4 times negative 4 is positive 16. And when you multiply the diagonals, you'll get negative 4 plus negative 4, which is negative 8. And that works with the negative 8 in the middle. And what you'll notice now is that you have 2 of the same factors. So when I go to factor it, I'm going to go x minus 4 times x minus 4. And because they're both the same, I would write x minus 4 squared. And even Dessine agrees. So that is how you can do it using the plus still, or you can use the formula over there. But now we're going to ask you to do these examples on your own, and we'll see what you come up with. Another thing I wanted to show you is just another way that you could use the factoring to solve a problem. In this case, what you'll notice is that instead of it being 1x squared, like it was in the previous example, now you have a 9. But again, I'm going to do it both ways. The key here is to, it's asking you to find the length of a side, by the way. I don't know if this is confusing to you, but what we know is that the area of this square is 9g squared plus 12g plus 4. And they want me to know what the length of a side is, which doesn't really make sense right now, but first and foremost, we want to break this down. So again, we want to have an a squared and a b squared. So if I choose a to be 3g, then a squared would be 3g squared which would be 9g squared. So that's what my A is going to be. My B, if I make B equal 2, then B squared will equal 2 squared, which is 4. And that's what is there, 4. So according to my formula, I need to check my formula here. So my A squared is correct, 9g squared. My B squared is 4, and I need to check the plus 2AB. So the A is 3g, the B is 2, so I need to check that that's actually 12g. And 2 times 3 is 6, and 6 times 2 is 12, so 12g, so it works. So the factored form would be to go A, which is 3g, plus, because we have a plus right here, plus 2 quantity squared, which means that each side of the square is 3g plus 2 and 3g plus 2, and then 3g plus 2 times 3g plus 2 would equal 9g squared plus 12g plus 4. So when it says find the length of a side, the length of a side is 3g plus 2. It also makes sense that if this is a square, the two sides would have to be the same, 3g plus 2. So again, if you want to do it the other way, the other factoring way, then again I'm looking for factors of 9, which are 3 and 3, factors of 4, which are 2 and 2, and when I multiply the diagonals, I get 6 plus 6, which is in fact 12. So it works. And again, I have the same factors. So I have 3g plus 2 times 3g plus 2. And because they're the same factor twice, I get 3g plus 2 quantity squared. And either way, I get the same answer. Alrighty, so that's how you do it when you have a number in front of the g squared. So now I will have you guys factor these three, and all of them have a number in front of the x squared. Okay, so then I want to go to the other special case of factoring, which is a difference of two squares. And again, we talked about how whenever you have a minus b times a plus b, you get a squared minus b squared. So we're going to use that and again try to factor in just like before. There are two ways of doing it. You can do it the way that we've been doing with the little plus, or you can use the formula. So first I will show you using the formula, and then I will show you using the previous method. So again, you want to identify what A is. A is, in this case, x, and then B, because this is a 64, would be 8. So you would get A squared is x squared, and B squared is 8 squared, which is 64. So in this case, you don't have to check the 2AB part. So once you've done that part, when you factor it, you just use this formula, which is A minus B. So this would equal A minus B, A plus B. And you can check it by foiling it if you want to. You could go back and first outside, inside, last, and you can check it to see if in fact you get the right answer, but I can assure you that it's correct. So then how do you do that with the other method? Some of you like to be really consistent and always use the same method. So how would you do it with the other method? Well, it might help to rewrite the problem as x squared plus 0x minus 64, so that you have three terms again. And when you do that, it might become more clear to you that the middle term is missing, and so the middle term is 0. So when you're looking for the diagonals to add up, you want them to add up to 0. So what's going to happen is you're going to put a 1 and a 1 for the 1x squared, and the factors of 64 are still going to be 8 and 8, but one of them is going to be negative because you want a negative 64. And when you add the diagonals, you're going to get a positive 8 and a negative 8, and that's going to add up to 0, which is what the middle term is because it's not there. So once you've got that to work, you write out your factors as x minus 8 and x plus 8. And so you see this method still works when you don't have a middle term. So now you can try these expressions, and then I will give you a couple of more examples of tweaking it. So here's another one where the middle term is missing. You have the x squared term and the constant term, but there's no linear term, there's no x term. So again though, what you want to do is you want to say that a equals, in this case, 2x, and then that way, when you get a squared, it'll be 2x squared, which is then 4x squared, which is in fact what we have. And then b would be 11, because b squared would be 121. Okay? So in that case, you just have to adjust your a value because it's got two parts, the 2 and the x. So, but again, the answer would be 2x minus 11 and 2x plus 11, and then you'd be done. And if you use the other method, you would have 4x squared plus 0x minus 121, and the factors of 4 would be 2 and 2, and the factors of 121 would be 11 and 11. One would have to be negative so that you could get a negative 121. And then when you go 2 times negative 11, you get negative 22. And then you add up to positive 22, and you get 0, which is what you want. So then you have your factors of 2x plus 11 and 2x minus 11. And just like that, you get the same exact answer. So I'm not sure if there's really a way of saying that one is easier than the other. It's probably just a matter of preference. You can either use the formula or you can continue to use this little plus thing. And then I have one more example for you. Well, this is your do-it-yourself problems. And then we have one more example for you. And that is when you can factor something out. Right now, when you look at this problem, what the difference between this one and all the other ones that we've done is that all the other ones had perfect squares, like 9s and 4s and 1s. But there's nothing squared that is 10. Like nothing squared is 10. So this one doesn't appear to fit the format. But what you want to do in these kinds of cases is try to see if you can factor out something else first, and then maybe it'll become more clear. For example, I can look at these two terms, and it appears that they both have a 10 in common. Both 10 is divisible by 10, and 40 is divisible by 10. So what if I factored the 10 out first? Then I would get x squared, because 10 times x squared is 10x squared, minus 4, because 10 times 4 is negative 40. And now it's factored. Once I factor it, now the part that's in the parentheses appears to be a difference of 2 squares, where a is x and b is 2. So a squared would be x squared and b squared would be 2 squared, which is 4. And so now I can continue to factor. I still have the 10 from before, and now I can factor out the x squared minus 4 as x minus 2, x plus 2, and now it's completely factored. And if you want to do it the other way, the same thing I would advise you to do. You still take out the 10, and then when you do this, you have you're using the 1x squared, so you put 1, 1, and then 2 and 2 for the 4. One of them has to be negative, and you have negative 2 plus 2, which is 0, and it should be 0 because there's no middle term. And so then your factored form would still have the 10 out there, and you'd have x plus 2 and x minus 2, and you'd get the same result as the previous example. So now you can try these guys. Remember that in these cases you want to make sure that you factor out what they have in common first, and then the difference of 2 squares will become obvious. So good luck with that, and I will see you in class.